My name is Emily Kenney, and my final optimization project was optimizing university recruitment for engineers. The problem is that the medical device company that I work for in Chicago, Illinois, has no established university recruitment plan for our engineering team, and students are typically just hired from alumni universities. So the first objective is to improve quality of student interns and new hires, and the second objective is to decrease the business costs for travel. The search technique used was heuristic, and the search space was continuous for the Pareto front due to the genetic algorithm multi-objective function in MATLAB, but it was plotted along with a discrete set of the 341 engineering programs. The three variables needed to solve this optimization problem are the rank x1, the distance from Chicago x2, and the number of students x3. The engineering schools used were from the ABET accredited engineering schools on the ABET site, but their major resource was engineeringschools.startclass.com. This site provides a rank that's not only determined by the U.S. News rank, but also includes selectivity, department expenditures, and other factors. This site also includes the number of engineering students in an engineering program. This is important because the more engineering students, the more likely it is that there is someone interested in our company and that we could hire on. The details of the standard design optimization model are shown. Function 1 includes the rank minus log of the number of students in the engineering program. This log function was used because the number of students in the engineering programs range from 42 to 10,202, and it's important that the number of students does not outweigh the rank and quality of the school. The second objection function was found from looking at the cost of travel through airlines, and the cost per mile is roughly 11 cents with a baseline fee of $50. Implemented in MATLAB, you can see that the functions are defined. GA multi-objective and GA plot Pareto were used to plot the Pareto front, and then the individual points were also plotted as well. The constraints shown, G1 through G6, define the outer limits of the rank of the school, the distance, and the number of students in the engineering programs. These are the results. You can see that the Pareto front is plotted in orange with the individual university values plotted as blue dots. In order to get a sense of the data, I looked at the three outliers. The outliers include the University of Hawaii at Manoa, University of Alaska Fairbanks, and Oral Roberts University. This makes sense because of the far distance between Chicago with Hawaii and Alaska, and Oral Roberts University ranked the lowest among the engineering schools. Zooming in on closer to the Pareto front, it is easier to see which blue dots are closest to the Pareto front. Due to the nature of the genetic algorithm, the Pareto front was not always the same, and in fact, sometimes the Pareto front was very small, where the L only was about 0.01 on both the X and Y axis. This indicates that the area of interest is in the bottom left-hand corner, as both functions are increasing over the area shown. In order to more quantitatively determine which universities would be the best recruitment targets, the distance from the point of the university to the nearest point on the Pareto front was found. This resulted in the top 10 universities shown with the purple stars. These stars are associated with the following target universities: University of Illinois at Chicago, University of Illinois at Urbana-Champaign, University of Michigan, Northwestern University, Illinois Institute of Technology, Georgia Institute of Technology, Purdue University, University of Notre Dame, Johns Hopkins, and University of Wisconsin-Madison. These results are very significant to my team because by hiring a higher quality of student, we will increase our team productivity, which will increase our product quality, and thereby increase patient quality of care around the world.